One of the most important aspects of algebra or pre-algebra is the element of solving equations. When we're solving equations, we're asking if the left side of a certain in the beginning part of what you're doing, if the left side is equal to the right side, for example, or if, for example, a question is negative 4 a solution to 8 minus 2x is equal to 5. So they're asking you, if you were to plug in a value into a certain equation, will the left side of the equation equal the right side of the equation? That's what they're asking in some of these problems. So let's look at a few examples here of solving equations involving integers. Very important topic, and so make sure that you pay attention and that you master the concept before you. So if you have any questions, please feel free to reach out. Let's go ahead and try a few examples. So we'll start right away from example 1, where they're asking you a question like, is negative 6 a solution of the equation 2x plus 5 is equal to negative 7? That's what you were asked. And I'm going to use a different problem, as I said, something like, is negative 3 a solution to 8 minus 3x is equal to 5? If someone says, is minus 3 a solution to that? What that means is that you're supposed to plug that in for x and see if it gives you the right, if the left side equals the right side. So think of this as the left-hand side and this as the right-hand side of the equation. So if we plug in at negative 3 there, then this is what we're going to have. We're going to have 8 minus and then 3 and then into negative 3. So this becomes 8 plus 9 actually, because negative 3 times negative 3 is positive 9. And that's equal to 5. We're asking a question, and 8 plus 9 is 17, and that is not equal to 5. So the answer is false. Negative 3 is not a solution to this problem. So that's what they start off the section with discussing. So that's one way to approach equations. The other way to approach them is just to solve them algebraically, and we're going to be talking about that in this section. So there's also another video you'll see from my algebra series that is included in this section that you can watch, which also shows how to solve equations of different types. So what you do is, when you're solving equations, you basically look at the left side of the equation. Generally, I recommend that you try and put on the left side, you try and put any variable. So let's say we have an x here. X plus 10 is equal to 20. So the variable is x, and I'm solving for x. Let's call it y, just so it's clearer on the screen. But if we're doing y, so let's see. Actually, we'll just keep it as x. So x plus 10 is equal to 20. If I'm solving for x, then I need to get rid of the 10. And the way I get rid of a positive 10 is by using a negative 10. It's opposite. It's inverse. Because if I use a negative 10 on the left side of the equation, it means that there will no longer be a 10 over here. So now I only have x on the left side of the equation. I don't have anything else on the left side of the equation. So that x then is equal to, but here's the rule. If you subtract 10 from the left side, you have to subtract 10 from the right side as well. So that's where you have 20 minus 10, and the answer is 10. So on the left side, you subtract 10. On the right side, you subtract 10. And your final answer is 10. So x is equal to 10. So that is one thing to keep in mind with solving equations. You basically do the same thing you do on the left side of the equation. You do that on the right side of the equation. And then you can check your work by plugging back the 10 that you just got, right? X is equal to 10. So 10 plus 10 is 10 plus 10, 20. Yes, we know that's true. That equation is good to go. So that's one thing to keep in mind in solving equations. Now we're going to look at another situation where it's a little longer, but it's same idea. And that occurs when something like y plus 4 into negative 4 is equal to negative 10 plus 6. So imagine if someone gives you this. Y plus 4 with the negative 4 there is equal to negative 10 plus 6. That means that the 4 and the negative 4 multiply. So you get y minus 16 is equal to negative 10 plus 6. So notice that, again, using PEMDAS, we have a multiplication section happening there. So y minus 16 is equal to, and then on the right side here, negative 10 plus 6 is negative 4. Now we want to get rid of the 16, the negative 16. So what we do is we add 16 to both sides. So if you add 16 to both sides, you actually get y is equal to 12. So the answer to this one is y is equal to 12. You could plug that back and you get 12 plus 4 and then times minus 4. And if you do it this way, you get 12 minus 16. Is 12 minus 16 equal to negative 10 plus 6? 12 minus 16 is negative 4. Negative 10 plus 6 is negative 4. So my answer is correct. This is the solution. Very good. In solving equations, you're not always to be having a situation where you're adding and subtracting. Sometimes you might have multiplication involved. So you might have a problem like negative 3y is equal to 21. Solve for y. In this case, we have a situation like this. We want to get rid of this negative 3. But whatever we do to the left side, we must do to the right side. So we're going to divide this by negative 3, and we're going to divide this by negative 3 as well. So y is equal to negative 7 actually, because I divided the left side by negative 3, and now I have 21 divided by negative 3, and that gives me negative 7. So that's how I do that problem there, is I divide both sides. So the opposite of addition is subtraction. Okay, so the opposite of subtraction is addition. The opposite of multiplication is division, and the opposite of division is multiplication. In this fractions that we're working with, or in this equation, sorry, we're working with. So when you have a positive number and you want to get rid of it, you add the negative of that number. If you have a negative number and you want to get rid of it, then you if you have a negative number and you want to get rid of it, you use the positive. If you have a multiplication, you use division. If you have division, you use multiplication to get rid of something. So for example, if something is in the denominator, if there's a division factor, then you go ahead and use multiplication to get rid of that. So that's how you do this, with addition, subtraction, multiplication, and so on and so forth. You use the opposite operation, and that's how you get your answer. So that's what the next section of the book talks about, is using multiplication and division. We've looked at an example of multiplication. Let's look at an example of division. So you have t over 5 is equal to 10. So you multiply both sides by 5. And so you get t is equal to 50. So t is equal to 50. That's one way to get t if you're solving for t. You multiply both sides by 5, for example, and in this case, you get t is equal to 50. So that's what we do for multiplying and dividing. There are times where we basically have multiple steps that we have to get through. Well, we might have to add and then do other things. So this is what's interesting. You've learned about PEMDAS. When you're solving equations, it's actually you go backwards. You don't do PEMDAS. You go the other way. So for example, x over 4 plus 12 is equal to 6. If you have a problem like this, the first thing that you should actually consider is subtracting the 12. So you actually get rid of the 12 first. So you have x over 4 is equal to negative 6. 6 minus 12 is negative 6. And then you multiply both sides by 4. And so you get x is equal to negative 24. So notice that we did the addition and subtraction part first before we multiplied both sides to get the answer that we were looking for. Please remember, especially if you've never seen equations before, watch the other video. If you just want to take good notes and then revisit this topic at a different time, that is completely fine. I just want you to be aware of that. So this is just getting you going, helping to explain the role that of integers and equations involving integers. So please keep that in mind. Don't worry if you've never seen equations before. You'll see them again and again. I just want to introduce it to you now. So you could check your this negative 24. You could plug it back in to check if it's valid. And that is completely fine. The book goes on to give you a few more examples. Let's look at a few more examples here. So we could take 12 is equal to 16 minus 4t, for example. So we subtract 16 from both sides. Now, ideally, as I've said before, I like to have my variable on the left side. So I can use, now we're looking at a symmetry here. I just put my left side of the equation on the right side, and that which was on the right side, I put on the left side. I didn't switch any signs. I just literally allowed it to switch around. Everything on the left going to the right, everything on the right going to the left. They didn't cross the bridge. I just switched the point of view that I'm looking at them at so that I can have the variable on the left side. Now, if you don't care where your variable is, that's fine. I just want to let you know that generally having the variable on the left side and then solving and getting your answer on the right side is very common. So if we have negative 16 here on both sides, we have negative 4 is equal to negative 4t. So then we divide both sides by negative 4. So t is equal to 1, actually. You could plug that back in to check your work, and you'll find out that 12 is equal to, you have 16 minus 4t, and that becomes 12 is equal to 12, and that is correct. That is correct. So something to keep in mind with solving equations. We have one step at a time, and we can get to our destination. They give you a few more examples here. I highly recommend that you just read through, see the different examples they give you. They give you a word problem at the end, and they explain setting up the equation. For example, here's a different type. After withdrawing $100 from your account, you find out that you are overdrawn. After withdrawing $100 from John's account, John finds that he's overdrawn by $15. What was his account balance before his withdrawal? So basically, if you had $100 taken out of a bank account, there was a certain balance, and then you took out $100, and if that resulted in you having $25, for example, negative $25, you can solve to find out where you started. So again, we're going to add 100 to both sides. If we add 100 to both sides, B would be equal to 75. So let's say you had $75 and you didn't know, and you used your ATM card, which is not good at this point because you're going to have a negative value. Notice that you have to look at the balance. But because the person didn't look at the balance and they took out $100, now they're at $25. So see how we set up the equation. John took out $100 from his bank account, and he ended up with a negative $25 balance. What was his balance before he took out the money? And we solved, and we found it to be $75. So something to keep in mind with these kinds of problems. So feel free to read example 10, example 11, read the whole, we're reading through the section, looking through the different nuggets they give us, and then we use that for the problems. For the practice exercises, I highly recommend doing number 1 to 67 odd problems. So 1 to 67 odd. And then if you want to try the word problems, it's up to you. But maybe trying you could try a few of those if you want, just for fun. So, but I would say definitely from 1 to 67 odd. Please let me know if you have any other questions. Keep up the good work, and we'll see you in the next video.